Welcome to today's podcast on the role of aerobic and anaerobic microbes in the soil, especially in the context of biochar. We are diving deep into the fascinating world of soil microbiology, focusing on the crucial role that biochar plays in promoting an aerobic environment in soil. I have seen many people working with anaerobic processes of the various types of biomass, let us say during composting, as well as creating some inoculants or enzymes or fermentation processes. All these things where the anaerobic microbes take over and they disintegrate, and there the ultimate product created at the end loaded with anaerobic microbes is not what to be applied directly as inoculant material to the biochars. So this is where my conversation happened with many people, and what we need to do in the anaerobic treatment of materials. It has its own advantage of doing so, including the process of say cow dung, urine, then even milk, curd. So various products that we bring in Indian traditional agriculture, where we say Panchagavya is one method, Jivamrut is another method. So all these methods are very much useful for the soil and also to add along with the biochar. But here it should not be added directly. So this is where my discussions or arguments happened with many people. To bring that clarity, I am trying to explain here more elaborately. So here if we say it plays a crucial role in helping the biochar also. Here we will explore why maintaining aerobic conditions is vital for soil health, how biochar helps achieve this, and the interaction between aerobic and anaerobic microbes. We will also discuss practical examples, including how anaerobic processes like fermentation can be integrated into soil management strategies. And by the end of this my podcast, you will have a deeper understanding on how to effectively balance these processes for optimal soil health. Understanding aerobic versus anaerobic environment. This is very important, very fundamental also in soil science. Soil ecosystems are teeming with life, from tiny microbes to larger organisms. Say, microbes is a general broader term, where fungi is another life existing in the soil, protozoa, nematodes, arthropods, all these play an important role and they maintain the soil health. And one of the important critical distinctions among these microorganisms is whether they thrive in oxygen rich aerobic or oxygen poor anaerobic environments. So this both environments are good for microorganisms, but there are categories of organisms. So which thrive more in anaerobic, which thrive more in oxygen rich aerobic environments. So aerobic bacteria and fungi are essential for breaking down organic matter, cycling nutrients, and, nutrients, and promoting good health of plant growth. They require oxygen to survive and perform their functions effectively. On the other hand, anaerobic bacteria can survive in oxygen depleted conditions such as waterlogged soils or compost heaps. Biochar is a highly porous form of carbon created through the pyrolysis of organic material. This is the nature of the biochar actually, means its characteristic, and can significantly enhance the aerobic conditions in soil. Its structure provides an ideal habitat for aerobic microorganisms while also improving soil structure, water retention, and nutrient availability. If you see the environments within the soil, most important environments are this aerobic environment that need to exist. Then the hydrological means water environment and microbial environment, that is biodiversity. So biochar provides habitat for all these environments together. That is the beauty of the biochar. One of the key benefits of biochar is its ability to create and maintain an aerobic environment in soil. The porous structure of biochar offers a vast surface area where aerobic bacteria and fungi can colonize and thrive. These microbes are essential for breaking down organic matter into humus, which is crucial for soil fertility. However, if anaerobic microbes or enzymes enter the pores of biochar, they can outcompete aerobic microbes. Here I give an example. Say if there is a movie theater and there is youth and they have occupied the seats in the theater. So youth want to enjoy, so they shout while watching the movie and they enjoy like anything. Say in the same movie theater, if the elderly people or senior people, they also want to see the movie, for them it will be a little bit disturbing. So when we have two kinds of categories of microbes, say aerobic and anaerobic, if anaerobic microbes have already occupied the seats or the places or the pores in the biochar, then there is less chance for aerobic microbes to go and reside there. So this is a peculiar condition. So let us not inoculate or introduce these anaerobic microbes into the biochar. So it will reduce the effectiveness of biochar in supporting the soil health. And to prevent this, it is important to oxygenate anaerobic microbes before they come into contact with biochar. Actually, this procedure is very simple. See, always I say a small analogy. The cockroach loves the gutter, that is the nalas or anaerobic conditions, and it can thrive there. So, if we take out a cockroach and wash it cleanly with clean water and try to put in fresh water, it might die. Because that environment is not what it is used to. Its survivability will be very difficult, like that. So, when we oxygenate the anaerobic microbes, most of the anaerobic microbes will not survive and they die. When they die, they release the liquids. These liquids contain all the nutrients, and these nutrients are in the available form for the plants, where plants can take and they thrive. So this is what happens in this process. At the same time, these nutrients can also be used by aerobic microbes or other living things within the soil. So this is a very simple way of explaining things. So here what we can do is by introducing air bubbles or using stirrers to mix them, so that we ensure that they are exposed to oxygen for at least a few days, maybe 3-4 days like that. Let us say we have prepared the Jivamrut, Panchagavya and all that. So let us oxygenate with these methods. So we can get nice air bubblers from the aquarium shops or even aquaculture farms also. They use different methods like propellers, the churning blades they use. So we can introduce the air into these anaerobic mixes and oxygenate considerably, and then you can apply. So here how to apply the anaerobic cultured the inoculants or liquids or enzymes into biochar. So here is this solution. By ensuring that biochar remains a heaven for aerobic microbes, we can enhance the biological activity in the soil, leading to better nutrient cycling, improved soil structure and healthier plants. Moreover, the integration of anaerobic processes into the soil management strategy, such as using fermented compost, can further enrich the soil. The acids produced during anaerobic fermentation help to balance alkaline soils, making nutrients more accessible to the plants and aerobic microbes also. The problem of pH in the soils is a big issue many places. Too much of acidic soils or acidity in the soils will leach out the nutrients and will not help the plants to take them. That is one big issue. The other way, alkaline soils, they hold lots of nutrients, but they will not release to the roots of the plants. That's another big issue. So pH close to neutral conditions is always better. But acidity, slight acidity helps a lot for nutrients also, so that which are available and the plants can take faster. So this is where the acidity or the lower pH values created by the fermentation in the process of anaerobic methods is helping the soil, especially microbes and plants, to take all the nutrients. Again, elaborately let us understand the purpose of adding anaerobic microbes to soil. You might wonder why, if anaerobic microbes are so beneficial, we added anaerobically generated compost, slurries, inoculants or microbes to the soil. You might wonder why, if aerobic microbes are so beneficial, we added anaerobically generated compost, slurries, inoculants or microbes to the soil. The answer lies in the unique contributions that anaerobic microbes make, particularly after their death in an aerobic environment. The things I explained just before. When anaerobic microbes are introduced into an oxygen-rich environment, they eventually die due to the lack of conditions that support their survival. However, during their decomposition, they release nutrients that can be readily absorbed by the plants. This process effectively turns the dead anaerobic microbes into a nutrient source for the soil. Furthermore, the acids generated during the anaerobic processing of organic materials can be particularly beneficial when applied to alkaline soils. The acidic conditions help to neutralize the soil pH, making essential nutrients more available to plants. This process also supports the activity of aerobic microbes, which thrive in a well balanced, slightly acidic to neutral pH environments. If soil loves aerobic microbes, once we have applied aerobic microbes by different means to the soil, they exist forever because the environment by definition is aerobic. Whereas the anaerobic microbes, they need to be added again and again. So that is the reason when people prepare the Jivamrut and all that, they add again and again. Because if they have added once, over a period in the aerobic conditions, they tend to die. So again they have to bring back. So that's why the process continues. And this is the reason we see the slurries or compost prepared in anaerobic methods are applied to the soils. It is not about promoting anaerobic conditions but about harnessing the nutrient content of anaerobic microbes once they transition into an aerobic environment. The key is to balance the two, ensuring that while anaerobic microbes contribute to nutrient availability, the soils remain predominantly aerobic, supporting the long-term health of the soil ecosystem. Again, the importance of aerobic microbes for soil health. The soil ecosystem is highly complex and both aerobic and anaerobic microbes play their roles. However, aerobic microbes are generally more beneficial for soil health. They are involved in critical processes such as the decomposition of organic matter, nitrogen fixation, and the suppression of soil-borne pathogens. These are very important factors. Aerobic conditions in soil also promote the growth of beneficial fungi which form symbiotic relationships with plant roots, enhancing nutrient uptake. These fungi such as mycorrhizae rely on oxygen to thrive and are crucial for the health of many plants, especially in nutrient-poor soils. On the other hand, an overabundance of anaerobic microbes can lead to negative outcomes such as the production of methane, hydrogen sulfide and other gases. These are also greenhouse gases which are harmful to the plant roots and contribute to global warming. Moreover, anaerobic conditions can promote the growth of harmful pathogens which can negatively affect plant health. In the recent past, I am experimenting in various areas where I am encouraging people to uproot the native plant. It could be weed also, the small plants, and smell the soil that is attached to the roots. That is giving a sense of what kind of microbes are there in the soil. If the smell is very pleasant or sweet, sweet means the roots are also exudating the sugars, which is very much important for microbes to survive. So that gives a healthy root system, and we can make based on the root density also, the number of root hairs and all that. So even for the same species pulled from two different places, we can see these differences also. And here Microbes in the soil testing through smell is something we could teach even kids because their senses are very sharp, and as a child they should learn these things. Healthy soil that is rich in aerobic microbes typically has a sweet, pleasant smell, often likened to the scent of fresh earth or a forest floor. Otherwise, just before rains, we get the smell all over. And in contrast, soil dominated by anaerobic microbes tend to have a foul odor, indicative of the presence of harmful gases and pathogens. This sensory evaluation can be a valuable tool for farmers and gardeners, allowing them to gauge the health of their soil and the effectiveness of their biochar and composting practices. Finally, we need to understand that both aerobic and anaerobic microbes have their roles in the soil ecosystem. Maintaining predominantly aerobic environment is the key to ensuring long-term soil health, and biochar plays a crucial role in creating and sustaining this environment by providing a habitat for aerobic microbes and improving soil structure and nutrient retention. The strategic use of anaerobically generated compost and slurries can complement this by providing a source of nutrients as anaerobic microbes die off in aerobic conditions. Additionally, the acids produced during anaerobic fermentation can help to balance alkaline soils, making nutrients more available to plants and supporting aerobic microbial activity. However, we must take care and ensure that anaerobic conditions do not dominate, and this can lead to negative outcomes for soil health and plant growth. The interplay between these two types of microbes is very complex, but by understanding and managing it, we can create healthier and more productive soils with biochar. Thank you.